All right, let's review ratios of similarity. When we are talking about similar figures, remember that everything within the two triangles in terms of length is proportional. Our corresponding angles are congruent, but our side lengths are all proportional with what we call the scale factor or the linear scale factor. When we start talking about perimeter and area, those same truths hold. The only difference for us with area is that because we are magnifying every side of our figure, that means our area is actually the scale factor squared. So we need to multiply by 2 of them. Okay, so if for example, my scale factor is 3 and I have a rectangle, length times width are both expanded by 3, so I'm actually expanding by 9 for my area. Okay, but the first thing we need to do is determine our linear scale factor and remember how to do this. What we want to do is look for my corresponding sides because I know my figures are similar. So I'm just going to use 4 different colors to highlight the different correspondences here. Okay. And then I'm going to look for which set has numbers in both figures. So for example, this 3 and this 6 match up. So I'm going to use those numbers to create my scale factor. So I want to start in figure ABCD. So that's my 3. And then go to figure WXYZ. That is my 6. So my linear scale factor should be that 3 over 6, which you can reduce to 1 over 2 if you want. So I'm going to go ahead and do the 1 over 2 and submit that. And there we go. Next, what do we do with our scale factor? And this is what I was talking about on the previous screen, where if we have our linear scale factor, then our area factor is that squared. If I know the scale factor, that is equal to the scale factor for our perimeters, because perimeter is still a linear unit of measure. So if my linear scale factor is 12 over 44, what is my area factor? So all I need to do for that is take that 12 over 44 and square it. And remember, when I'm squaring a fraction, that means I square the numerator and the denominator. So 12 squared is 144, and 44 squared is 1,936. Now, this fraction, 12 over 44, is reducible, so you can reduce first to square smaller numbers. If we do that, we end up with 3 over 11, so that would give us 9 over 121, which still would work for our area factor. If the scale factor of our perimeters is 16 over 24, what is the scale factor of the areas? And we do that same concept. To get to the area, we square. So again, this does reduce to, I think these are both divisible by 8, so we could do 2 over 3. But if you want to stick with the 16 over 24, then that is 16 squared, 256, over 24 squared is 576. Again, if I do 2 over 3 and I square that, that would just be 4 over 9. A lot simpler. But if you want to stick to not reducing your fractions, this is fine as well. Okay. Now, I'm giving you the area scale factor in this one. So if the area factor is 144 over 64, how do I get the perimeter factor? We go backwards. So instead of squaring, we square root. And not just the numerator, we square root the entire fraction. So the square root of 144 over the square root of 64 gets me 12 over 8. And again, I can reduce that if I want to, but I don't have to. Okay, so if you start with the area, that is in square units, and we have to go backwards to perimeter, that is in linear units, so we want to undo the squaring. Okay, use those clues to help you. All right, question 3. Given the two polygons are similar, find the ratio of the side lengths. Go from red to blue. So I'm looking at 14 to 28. So 14 over 28. I can reduce that. These are both divisible by 14, and I would get 1/2. The ratio of the perimeters should be the same thing, 14 to 28, or 1 over 2. The ratio of my areas will be this 14 over 28 squared. 14 squared is 196, and 28 squared is 784. Okay, again, if it's 1/2, if you reduce that to 1/2 first, then this would be 1/4. Find the area of the red polygon. Okay, now this is where we set up and solve a proportion. We take our ratio of areas, our area scale factor, and this, remember, is red over blue. I know the blue area is 224 square yards, and I want to find the red area. Red to blue, red to blue. Now we cross multiply. So 196 times 224. These are the big numbers. So this is where it's helpful to reduce first if you want to reduce the size of these calculations. Divide by 784. And you get x equals 56. So we're going to type in 56 here. And if you do this work, I would love for you to upload it and show me so I can see how you set up your proportions. Okay, let's keep going. Question 4, same thing. Find the ratio of the side lengths, red to blue, so 10 to 20. Again, that reduces to 1 over 2, so let's use 1/2 this time. The ratio of the perimeters will be that same value, 1 over 2. And that means the ratio of my areas is 1 over 2 squared. So that will be 1 over 4. So I am going to use that ratio, 1 over 4, to find the area of my red figure. Remember, we are going from red to blue. So I have 1 over 4 equals x over 544. Use my cross products. 544 times 1 is 544 equals 4x. Divide both sides by 4, and we get x equals 136. Okay, so I'll come over here and type that in. Okay, there we go. I got my points. So let's keep going. Question 5, same thing. Find the ratio of your side lengths, red to blue, 18 over 4. Now we can reduce that. Those are both divisible by 2. That would get us 9/2. So let's go ahead and use 9/2. for the ratio of my perimeters. So remember this, 18 over 4. I can divide them both by 2, and that gets me the 9 over 2. And that's what I'm going to use for the ratio of my perimeters. The ratio of my areas is going to be that 9 over 2 squared, or 81 over 4. So when I come over here, I'm going to put that in, 81 over 4. Okay. And now I need to find the area of the blue polygon. So I'm going to take my ratio, 81 over 4, and again, we're going from red to blue. I know the red area is 405. So red to blue, blue is my x this time. But the process is the same, cross multiply. So 81x equals 4 times 405. That's 1,620. Divide both sides by 81. And we get 20. So x equals 20. Okay, there we go. Now, if you get a decimal answer, I want you to know that is completely okay. That does happen, especially if we are dividing by 3 or dividing by multiples of 3. So if you get something like that, that is okay. Find the ratio of the side lengths, red to blue. So again, 20 to 15. 20 over 15 does reduce. They are both divisible by 5, and that gets us 4/3. 20 divided by 5 is 4. 15 divided by 5 is 3. Okay, so again, I'm going to do the same thing I did on the last problem. The ratio of my areas is that 4 over 3 squared. So 4 squared is 16, and 3 squared is 9. So now we are going to find the area of the blue polygon. So remember, we go from red to blue. So I'm going to set up a proportion with my 16 over 9. And my red area is 160. And then the blue area is my x. So 16x equals 9. Hold on, 9 times 160 is 1,440. Divide both sides by 16, and x equals 90. So my area here should be 90 millimeters squared, of course, but we're not putting the units of measure in yet. Okay? All right. 2 more. Find the ratio of the perimeters, and that is equal to the ratio of the sides. And again, we're going red to blue. So I'm going to have 5 to 10, and 5 over 10 reduces to 1 over 2. The ratio of my areas is that squared. 1 over 2 squared is 1 over 4. Now find the area of the blue triangle. We are going to take that 1 over 4 equals the red area of 5 over x. So x equals 20. Well, that's a nice simple multiplication there. If you use 5 over 10, you might have to do a little bit of dividing, because if we square that, we get 25 over 100. Set that equal to our 5 over x, and you get 500 equals 25x. If you divide by 25, that gets us x equals 20. So no matter which way you do this, you should get the same answer. Okay? We've got 1 more to go on this video. So let's give it a try. Question 8. 2 quadrilaterals are similar with a zoom factor, linear scale factor, of 5 over 1. Okay, so linear scale factor is 5 over 1. The smaller one has a perimeter of 45 and an area of 55. Now I'm putting this as P1 over A1 because now what I want to do is find P2 and A2. the perimeter of my large figure and the area of my large figure. So perimeter, remember, uses the linear scale factor 5/1. So that 5/1 will still equal the smaller perimeter of 45, and then this is my variable. So now if I want my smaller value in the correct spot, does that match up in the same position as the 5 or the 1? Which one represents the smaller figure? Well, the smaller number. So the smaller number goes in my denominator, since that's where the 1 is. And that means my larger perimeter will be in the numerator. So I am going to cross multiply, and I get my second perimeter is equal to 5 times 45, which is 225. Okay? Now for my area, I need to square my linear scale factor. So 5/1 becomes 25/1. And again, we're given the smaller area, so that goes in the denominator, and I want to find the larger area. So my larger area times 1 equals 25 times 55, which is 1,375. Okay, so now I just need to type these in. 225 and then 1,375. Do my answers make sense? Well, we're finding the perimeter and area of the larger figure. My numbers are larger than those that were given to me, so I think we're on the right track. Okay, and that's it.